Have you ever seen one of those big metal shipping containers sitting at a port or on a truck? Now imagine one of those, but instead of being filled with toys or bananas, it's packed to the brim with batteries. Not little AA batteries for your remote control, but thousands of powerful, high-tech batteries all working together. That's a battery energy storage system, or BESS, and they are incredibly important. They help us store energy from the sun and wind, so we can use it later when it's dark or the wind isn't blowing. They are like giant power banks for our entire electrical grid, keeping the lights on for everyone. Today, we're going to design one of these systems together. Our goal is to build a 5 megawatt-hour battery container. That sounds like a huge number, and it is. A megawatt-hour is 1 million watt-hours. To put that in perspective, a typical home in the United States might use about 30,000 watt-hours or 30 kilowatt-hours of electricity in a day. So, our 5 megawatt-hour battery could power over 160 homes for a full day. It's a lot of energy, and to build it, we need to start with the smallest part and work our way up, just like building with Lego bricks. Our mission is to figure out exactly what it takes to get to that 5 megawatt-hour target. How many individual battery cells do we need? How do we connect them to get the right voltage and energy? How much will it all weigh? We're going to walk through the math, step by step, using simple numbers and clear ideas. Think of it as a recipe. We have our ingredients, the individual battery cells, and we have our final dish, a fully functional 5 megawatt-hour energy storage container. By the end, you'll understand the science and engineering behind these amazing machines. So, put on your thinking caps because we are about to become battery system designers. We'll start with a single, small battery cell and see how, by combining thousands of them in a very clever way, we can build something powerful enough to support our modern world. It's all about taking a small, simple idea and scaling it up to do something truly magnificent. The science is cool, the numbers are big, and the result is a cleaner, more reliable energy future for all of us. Let's get started. Everything big starts small, and our giant battery container starts with a single battery cell. The cell is the fundamental unit of energy storage. For our project, we're using a specific type called a lithium iron phosphate, or LFP cell. These are popular for grid storage because they are very safe and last a long time. The cells we've chosen have two key numbers, a voltage of 3.2 volts and a capacity of 314 amp hours. Voltage is like the pressure of water in a hose, and amp hours are like the amount of water available in the tank. To find out how much energy one cell holds, we multiply these two numbers together. Let's do the math. Energy is measured in watt-hours. The formula is simple: energy equals voltage times amp hours. For our cell, that's 3.2 volts multiplied by 314 amp hours. When you punch that into a calculator, you get 1004.8 watt-hours. To make things easy, let's just round that to a nice clean 1000 watt-hours, which is the same as 1 kilowatt-hour. So, one single battery cell, about the size of a thin book, holds enough energy to run a small appliance, like a television, for several hours. This single number is our foundation. Why is this number so important? Because it tells us exactly how many of these building blocks we'll need to reach our massive 5 megawatt-hour goal. Our target is 5 million watt-hours, and each cell gives us about 1,000 watt-hours. It's like knowing that one brick weighs 1 kilogram, so you can figure out how many bricks you need to build a 5,000 kilogram wall. By understanding the energy of a single cell, we can plan the entire system. Every calculation from here on out will rely on this fundamental value of 1 kilowatt-hour per cell. So we have our basic ingredient, a 3.2 volt, 314 amp-hour LFP cell that stores approximately 1 kilowatt-hour of energy. It's the atom of our energy universe. By itself it's useful, but not powerful enough for the grid. To make it useful, we need to connect many of them together. The next step is to arrange these cells in a line, like a string of holiday lights, to build up the voltage. This is where the real system design begins to take shape, moving from a single cell to a high-voltage assembly.